All right, guys, time for my next video, the last one for this homework assignment, where I'm going to do numbers 20 through 27. The first four are going to be pretty easy. The last four are going to be trickier. Okay, they're going to be trickier. So let's try and figure this out. Okay, so in these problems, in every case, I'm giving you the formula. I want to know what the name of this substance is. Okay, now this is going to be easier because remember, it doesn't really matter in most cases how many of each thing are in the compound. You just have to identify what they are. So, for example, in number 20, Al is aluminum. All right. And P is phosphide. So that's the name. All right. Aluminum phosphide. Aluminum is always 3 plus. Let me actually just grab this up here. Save myself some time and just paste this into every single spot. Oh, did I mess this up? Let's see here. Control copy. Cool. And then I got to do like this. All right, so aluminum phosphide. Well, let's see here. Aluminum is Al with a 3 plus charge. Okay, I know that because I can just go here and take a look. Al has a 3 plus charge always. Okay, and phosphide has a 3 minus charge. I know. I go here, I find phosphorus. Boom, 3 minus charge. Okay, good. So there we go. So that's aluminum phosphide. No Roman numeral needed because aluminum always has a 3 plus charge. Let's try this one right here. BeCl2. Okay, well, Be is beryllium. And Cl as an ion is chloride. Notice how it doesn't matter that there's two here. I'm not putting any it's not dichloride. It's not chloride 2, okay? All that matters here is what the elements are. Okay, beryllium, I know, is Be. Right there. And the charge of beryllium is, let me check, Be, beryllium, 2 plus. Beryllium is 2 plus. All right. Chloride, we've encountered that before in this homework. Chloride has a 1 minus charge. Okay. So there we go. Cool. Next one, Ag2O. Well, Ag, oh, by the way, no Roman numerals because beryllium always has a fixed charge. Ag2O. I know that Ag is silver. It's one of those ones with a weird name, right? Derived from Argentium, okay? Where Argentina gets its name, all right? Ag is silver, and O, of course, is oxide, okay? Now, silver, what is the charge of a silver ion? Let's see here. Ag has a 1 plus charge, right? Silver has a 1 plus charge. So this is Ag plus, all right? Oxide. I know the charge of oxide. That's one of the most common ones. It is a 2 minus charge. Okay, so this is silver oxide. No Roman numeral because silver always has the same charge. Okay, last one. Li3N. Well, Li, I know Li is lithium. Okay, and I know N is nitride. Okay, now what's the charge of a lithium? Let's find out. Li, lithium, has a 1 plus charge. So this is Li, 1 plus. And nitride, oh, we've done that before, it is 3 minus. Okay, so again, lithium nitride and no Roman numerals needed. All right, because again, lithium always has the same charge. Remember, Roman numerals are only for those elements that have multiple possible charges. Okay, so there we go. Again, notice that for all these names here, it's just the name of the first ion followed by the name of the second ion. It doesn't matter how many there are of each. That does not impact the name. Okay, all that matters is what's the first one, what's the second one. Okay, very good. On to the next set. Now, these are going to be a little bit trickier, all right? And they're going to be a little bit trickier because all of these compounds are made with metals that have multiple possible charges. Allow me to demonstrate, okay? So CuCl3, okay? Well, I know for a fact that Cu is copper. And Cl, we've encountered it up above, is chloride, all right? Now, what is the charge of a copper ion? Let's take a look. Charge of a copper. Copper is not here. We are not given the charge of the copper. Oh no, This is the only thing I think in this entire homework that's going to challenge us a little bit, and that is this problem right here. All right, copper should have a Roman numeral here. All right, it should have a Roman numeral indicating what its charge is, but we don't know what its charge is. Well, we have to figure it out. Now, I think some of you who are maybe picking up on the mental math a bit quickly, you already know what the answer is. But what I'm going to do is I'm going to go to this ionic compound workspace, and I'm going to try and rebuild this molecule, work backwards to figure out what the charge of this copper was, okay? Now, it's CuCl3, and this Cl3 right here is going to be critical, all right? Because I know what the charge of a chlorine is. A chlorine has a 1 minus charge. Chlorine is 1 minus. Okay? Chlorine is 1 minus. So there's 3 chlorines here. There's 3 chlorines, all right? Count them with me. There's 1, 2, 3 chlorines here. A little bit. Cool. Okay. So there's 3 chlorines, and there's only one copper here to balance these 3 chlorines. So we're only allowed one shape to balance this. It's not going to be 2. All right. It can't be copper 2 because that doesn't balance all these chlorides. It can't be copper 4, all right, because that doesn't balance all these chlorides here either. Okay. It's got to be something else. I think you're like, oh, I understand, guys. You feel like you're watching an episode of Dora the Explorer here. Like, it's 3, Mr. Gucci. Jesus. Yes, it is. It is. Okay. Yes, this is copper 3 chloride because only a copper with a 3 plus charge could cancel out those 3 chlorides. Okay. So, yeah, this copper has a 3 plus charge. All right, format, text, superscript. So yeah, the name of this thing is copper 3 chloride. Okay, copper 3 chloride. This is critical. You have to include the name with the Roman numeral here. Okay, you need that Roman numeral because copper can have many charges. There's no such thing as just copper chloride because there would be a different formula, a different substance. It is copper 2 chloride, copper 3 chloride, copper 1 chloride. Okay, you have to give me the Roman numeral. In fact, all of these substances here are going to require that you give me Roman numerals. That's why I saved these for last. That's why these are the toughest problems, okay? Let's do the next one, PbO2. All right, well, I know what O is, all right? I know that O is, oh, it's right up there, all right? O2 minus, that's oxide, okay? That is oxide, okay? Whole thing, format, text, superscript, okay? Problem is though, lead can have many different charges. So what is the charge of this lead here? All right, we know that the name is going to be lead oxide. All right, what is that? All right, that's what we're here to find out. Now, once again, I'm going to go to my ionic compound workspace here, and I'm going to work backwards. I'm going to do a little bit of forensics here, all right? And we're going to trace back and figure out what must the charge of this lead be, all right, in order for it to cancel out 2 oxides. Well, again, the key is here, I'm going to look at these 2 oxides, all right? I'm going to grab these 2 oxides here. Oxide is a 2 minus charge, so here's an oxide. Here's another oxide. Now, I have to cancel out these 2 oxides with only how many leads? I'm only allowed 1 lead. So, I mean, you're looking at this and you're like, oh, is it a +1, Mr. Gucci? Is it a no? Clearly not. Clearly, a single +1 lead is not enough here. Okay. I know you're like, okay, again, let's cut it with the Dora Explorer crap. All right. Look, yeah, it's lead 4. All right. Lead 4. You need to have a single lead with a +4 charge to cancel out these 2 oxides here. So the name of this substance right here is lead 4 oxide. It has a 4 plus charge. Okay? Now I know this is kind of like a little inconvenient here. All right. That's why, these are more difficult questions. These are more rare. You're not going to come across them as often. Okay, let's try another one. Ni2P3. Right? Ni I know is nickel. All right. P is phosphide. Okay, cool. All right. I know that phosphide is, let me check here. Phosphide, phosphorus, 3 minus. Okay, so P 3 minus. All right, that is the phosphorus. Nickel, Ni with what positive charge? Let's take a look. Nickel, Ni, 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 Ni. Uh-oh, nickel is not here, guys. And that means that nickel has multiple possible charges. Once again, this is something that's going to need a Roman numeral to tell me what is the charge of this nickel. Okay, and once again, we are going to go to this worksheet right here. In fact, I'm going to do something different. I'm going to work this out manually. Okay, because you're not going to go through life having Mr. Gucci making worksheets to solve all your problems for you. You got to show some damn initiative. Okay, so nickel something phosphide. We know the formula is Ni2P3. Well then, what is the charge on that nickel? All right, Ni2P3. All right, let's see here. Okay, first of all, guys, pause this. I realize I made a typo here. This is currently unsolvable as is. So I'm going to just change this formula a little bit. Change that to a 3. Yeah. Wait. An important time for lesson, guys. I realized I had written a compound that did not and could not exist, okay? All these things are real. You can look up pretty much all of these on Wikipedia, okay? So yeah, the formula is Ni3P2, okay? Ni3P2. So let's solve this. To figure out the charge of this nickel, we have to look at these phosphoruses right here. So this is number 26. All right, so I'm going to draw this out. Here I go. All right. So this is Ni3P2. Now we know that a phosphorus has a 3 minus charge, all right? So this is P3 minus, and there's 2 of them, P3 minus, okay? That means that these guys are looking to each take in 3 electrons, okay? They're each looking to take in 3 electrons. All right, this one wants 3. This one wants 3 as well, okay? Now, to donate all of those electrons, 6 in total, we get 3 nickels, all right? So how many electrons is each nickel donating? Well, this nickel right here is donating 2. This nickel is donating 2. This nickel is donating 2. If you have to scrounge up 6 electrons and you have 3 nickels to do so, well, each one is going to get rid of 2 electrons, okay? So this is a nickel with a 2 plus charge. This is Ni2 plus, this is nickel 2 phosphide. Okay, guys, remember, the charges have to cancel here. So whatever negativity the negative ions bring to this compound, you need to make sure that the positive ions cancel it out. So 2 phosphides are bringing a total of -6. If you have 3 nickels to balance that out, each nickel must bring a positive 2. Okay, this last one right here. All right, let's just take a look at it. I'll solve this. This is the last one. All right, so CO3S2. I know that CO is cobalt. Okay, I know that S is sulfide. All right, let's see here. What's the charge of a cobalt? Cobalt is element CO. It's not here. It's not here because cobalt is one of those atoms that can have multiple charges, okay? So it's going to be CO with some charge. Now, the only way we can figure that out is to look at the sulfide here, okay? Sulfide, I know that sulfur, when it forms an ion, forms a -2 ion, okay? So, here we go. So what then is the charge on this cobalt? Well, we got to build this substance up. All right, we got to build this substance up. Quick edit to the formula. Once again, I messed up and wrote something that did not exist. I'm sorry, guys. I'm sorry. Merry Christmas. Merry Christmas, y'all. Okay, so the formula is CO2S3. CO2 S3. Cobalt with 2, sulfide with 3. So the only way we can figure out what the charge is on this cobalt is by building up this substance, all right? Figuring out how much negativity these sulfides bring so that we know how much positivity these cobalts need to bring. So 3 sulfides. So I'm going to do this one in the workshop, okay? 3 sulfides. Each one is 2 minus, okay? So there we go. So here are 3 sulfides, each with a 2 minus charge. Now we get to bring 2 cobalts to cancel this out. Maybe it's a +4. No, that does not work. So it can't be +4, all right? It won't be +2. You can't, if you have 3 2 minuses, you would need 3 2 pluses to cancel it out. So that can't be it. The answer at this point is 3. Okay, the answer is 3. Yes. Yes, there we go. We've done it. So each of these cobalts here must have a 3 plus charge. All right. Each of these cobalts here must have a 3 plus charge. So this is cobalt 3 sulfide. Cobalt with a 3 plus charge. Control copy. Control paste. Great. Okay, guys. So this is it. I hope this homework was helpful to you. Good luck.